Hello class. In this video, we study annuity. Section 8.5, annuity. Annuity is a type of investment. What a type of investment annuity is? Let's look at the definition of annuity right here. An annuity is a sequence of equal payments made at equal time periods. An IRA is an example of an annuity. So here the keyword in this definition, equal payments at equal time periods. That type of investment account or savings account is called an annuity. Does that make sense? I think an annuity is consistent with majority people's investment habits. For example, every month you contribute $100 to the account, or every year you deposit $1,000 in the account. Very regular. Yeah, equal payment, equal time periods. There are two types of annuity. The first type is called ordinary annuity. Ordinary annuity. The other type is called annuity deal. Our book only covers ordinary annuity. We do not cover annuity deal. Then what's the difference between ordinary annuity and annuity deal? Ordinary annuity, the equal payment is contributed, is made the end of equal time periods, the end of every time period. And annuity deal, the equal payment is made beginning of every time period. So that's the difference. Again, our book only cover annuity, ordinary annuity. Our book only cover ordinary annuity. So all the payments, even sometimes it will not specify, but we default all the annuity we study in this course will be ordinary annuity. That means that equal payments will be made the end of every equal time period. All right. Next definition, the value of an annuity. This is a very important concept. The value of an annuity is the sum of all deposits plus all interest paid. The value of an annuity includes both the contributions, the equal payments you made regularly, also the interest generated from those payments. The total, that's the value of an annuity. This formula is the value of an annuity when the interest is compounded annually. Also, you deposit your contribution to the account end of every year. So this is the formula. Value of an annuity, interest compounded once a year. If P is the deposit made at the end of each year for an annuity that pays an annual interest rate R, compounded once a year, the value A of the annuity after 10 years can be found by applying this formula. Very important thing I need to point out is P here is not principal. P here is not principal. You do not have a principal, by the way. I mean, you do not have the original principal when it comes to annuity. Your annuity account has zero money the very beginning, because we are talking about ordinary annuity. So by the end of every year, you contribute, you deposit your regular payment, and your interest is generated on those payments. So P here, again, is not your original principal. P here is payment, PMT. If it was me, I would actually change the P here to PMT. Then student will not have any confusion. Yeah, I will change the P here as PMT, payment, your regular payment. R here, obviously, is the annual interest rate in the decimal format. T here is time in year. Yeah, how long you are going to, how long you are going to keep depositing regular payment. And A here is the future value. A here again is the accumulated balance in your savings account, right? That is your future value. FV. A here is the future value of your annuity, or just the value of your annuity. Because the beginning, the value of your annuity is 0. Of course, A here is the future value of the annuity. All right, we do not spend time to derive this formula. Just know this is the formula to find the value of an annuity. Suppose the interest is compounded annually. Well, let's look at an example. Suppose that when you are 35, you decide to save for retirement by depositing $1,000 into an IRA at the end of each year for 30 years. If you can count on an interest rate of 10%, that is very high, every year compounded annually, find the following answers rounded to the nearest dollar. We have two parts. Let's do the first part first. How much will you have from the IRA after 30 years? So we are looking for future value, right? So we are looking for A. Since the interest is compounded annually and you deposit your regular payment end of every year, knowing those two things are consistent in annuity. If the interest is compounded annually, then you deposit your payment annually as well. They're always the same. Then we are going to use the formula in the box that we have just seen. A equals P times parentheses. No, actually it's a bracket. Again, what is P? P is not principal, okay? P is not principal. So P times a bracket. In the bracket, we have the compounding factor to the power of T minus 1. And the denominator, we have the annual interest rate. Let's plug in the value we have. P is the payment, again, is the payment, your regular payment, your annual payment. It is given $1,000. In a bracket, we have a difference. The first part is the compounding factor, 1 plus R. Our annual interest R is 10%. As a decimal, 10% is 0.1. Raised to the power of 30, because you are going to save for your retirement for 30 years. You're now 35 years old, right? In 30 years, you are 65. Then you can start to use your money. That's your plan. And minus 1 in the bracket, close the bracket. In the denominator, we have 10%, which is 0.1. Okay? Let me show you how do we use the calculator to compute. Yeah, of course, you can manually process some of the part of the expression. I'm going to show you the TI-84 calculator. Yeah, very, very important. I have emphasized this a lot. You need a TI-84 calculator. I'm not kidding. This is a fast-paced course, a lot of content in 8 weeks. With a good calculator, your job will become a lot easier, trust me. So let me share camera. Oh, I need a plugin. Give me 1 second. I apologize for that. I need a plugin in my documentary camera. Let's do it again. Share camera. Not yet. Documentary camera. Give me 1 second. Apologize for that. Try again. No? Let me look at HD camera. Let me do this first. Scroll this. Share camera. Oh, here you go. Sorry for the waiting. You can, skip that part. Yeah, are you able to see this? It's raining outside, so there's a highlight here. If I turn this off. Actually, yeah, this is good. This is good. All right. So let me show you how do I edit the expression in the TI-84 calculator. Let me share camera. Let me clear everything. I hope this is recording. You are sharing HD camera, okay? It seems it's recording. All right, so we have an expression, remember? If you go back the video a little bit, we have a quotient, right? Yeah, this is what I would do. I would enter $1,000, that's the payment, yearly payment, and then I give this the left-handed bracket. We don't really have a bracket, but we use parentheses. And I'm gonna give another parentheses. In this parentheses, we're going to have the compounding factor, 1 plus 0.1. Close the compounding factor. Raise the compounding factor to 30 years. Once a year for 30 years. And then minus 1. All right? And then close the bracket. Again, is the parentheses. And I'm going to enter. That's my numerator. And then divide the numerator by the denominator. Annual interest rate 0.1. And that's the quotient. I have 164494.0227. Okay, so I'm going to enter the value here. How do we round the result? Read the question. We need to round the answer to the nearest dollar, okay? To the nearest dollar. So that is going to be 164494. 164494. So think about it. It makes sense, right? Makes sense. $164,000. Because for 30 years, that's a very long term. Okay, let me share back. And hold on. So we're going to use this calculator. I'm going to show you a different way. I'm going to show you a different way to find the future value of the annuity. I'm going to show you a different way to calculate the future value of the annuity. So we're going to use the TVM solver in the TI-84 calculator. So let's go to apps. You see finance, right? And select finance. And the first function in the menu is the TVM solver. If you watch the previous video, you know what is TVM solver. TVM stands for time value of money. Money has time value. $1 today worth more than $1 tomorrow. A little bit more. I mean, maybe a lot more than $1 next year. Yeah. So we select that. The first item in this menu is big N. So the interest is compounded once a year and for 30 years. So 1 times 30, your big N is 30. The next item is the annual interest rate. Our annual interest rate is 10%, right? So you do not have to convert 10% to decimal when you use this app. Simply just put a 10 because the percent sign is already there. Yeah, you do not have to worry about the percent sign. Percent sign is already programmed in it. So you only need to enter the value in front of the percent sign. And PV, can you guess what does PV mean? PV means present value, right? Or the beginning value of your annuity. It is 0. PV of an annuity always 0 because we are talking about ordinary annuity. The very beginning, your account has nothing there until your first payment. PMT here is your regular payment, is $1,000. You know what? We are going to enter negative $1,000. And you do not enter minus 1,000. I'm going to show you what is negative. Do you see this key right here? Bottom right, this negative sign in the parentheses. So that is a negative, very, very important. Please do not use this minus sign. If you use the minus sign as a negative, the system will give you error. Again, if you want to enter negative value in the calculator, use this key, the negative sign in the parentheses. So negative 1,000. You might wonder, what is negative 1,000? Because your payment is out of your pocket. The money is going out. The money is going out. And future value is the value we are trying to solve for, right? So you can put a 0 there. You can put a 0 there. Just for now. We are going back later in a moment. Next 2 items, P per Y and C per Y. P per Y is the payment per year. How many payments do you deposit every year? Once a year, right? So it's 1. And C per Y. C per Y means compounded every year. How many times your interest is compounded every year? Annually, so it's also Y. Knowing that if you change the P per Y as 1, automatically your C per Y will become 1 as well. And the last item, in our calculator, it is default as an ordinary annuity. So please do not change it. Just leave it as end. Your payment is made at the end of every year. Okay, so let's go back to FV, future value of the annuity. And you can see it's blinking there, right? And you solve for that. Remember, how do we solve for that? Alpha, enter. The green key right here. Alpha, enter. Is 164494. Isn't the same with earlier? Same value, right? It's the same value. So that's the second method I show you. I'm going to show you the third method using Excel, maybe later. So let me share back. Go to our note. Okay, so I'm sharing my whole screen. And let's go back my notes. Yeah. We rounded the answer to the nearest dollar. So in 30 years, you will have $164,000, $164,494 for your retirement. Depends on the location. That money might be able to afford a small apartment, right? In the 55 plus community. So that's the first part. Second part of the question is to find the interest. How do we find the interest? The interest is your earning from the annuity. Let's firstly think about in 30 years, the value of your annuity is 164,494. How much money in that money is actually out of your pocket? Okay, you deposit $1,000 every year for 30 years. So in an account, you have 30 grand. 1, 2, 3. Those money is yours. Okay, over time you deposit, you contributed those payment. Those money is still yours, and we are going to use the future value of the account 164494 to minus the money you deposited, 30 grand. Once a year for 30 years, $1,000 annually. So yeah, 30 grand. 1, 2, 3. And the difference is 134494. 134494. So those money are the interest, is your gain, is your earning from investing this account. That's a lot, by the way, that's a lot. But 30 years is a very long time, and also 10% interest rate is very high. All right? And remember I mentioned we're gonna have 3 methods in total. If you look at my table note for annuity, I gave 2 examples because we only have 2 types of problems in this section, and 1 example for each type. For each example, I provide 3 different methods. The first method is you use the formula. I do not really recommend that method. Second method is to use the TBM solver. Very quickly, you can get a result. The third method is Excel. Excel, you can use this method when you work on your homework or double check your answer. The disadvantage of this method is you cannot use it when you take the test. That's not allowed. So let me show you how do we use Excel to find annuity, future value of annuity. So enter equal sign, FV, and then left-handed parentheses. And Excel will remind you, yeah, rate, annual interest rate 0.1, right? And comma, NPER. NPER is how many deposits you made in total, 30 deposits. And the PMT, you made $1,000. You can do $1,000 or negative $1,000, doesn't matter. Depends on how you adjust the sign when you look at the answer. And type is 0 because of ordinary annuity. Okay? Yeah. So, sorry, present value is 0. Present value is 0 for annuity. Type is 0, end of period. And close the parentheses. Do you see the same answer? Exactly the same. So we apply the 3 different methods to find the future value of the account of the annuity, and they result in the same answer. I strongly recommend you use the app to make your job easier, but I also recommend that you try the other two methods just to get a feeling. All right? So this example about the future value of an annuity is an annuity that the interest is compounded annually, and you also deposit your regular payment annually. What if you deposit your payment once a month, or once every half a year, or once every a quarter, or even once a day? So what if the other type of contribution style? So we have a new formula. This formula actually is the general formula for finding the future value of an annuity. Again, the number of times your interest is compounded every year is the same with the number of your contributions or payments every year. They are consistent. So in this formula, if n equals 1, then we got the formula that we had earlier. If n equals 2, that means you contribute once every half a year, and the interest is compounded semi-annually. If n equals 4, you contribute once every a quarter, and your interest is compounded once quarterly. If n equals 12, that means you contribute the end of every month, and the interest is compounded once every month. If n equals 365 or 360, then that means you contributed on a daily basis, and your interest is also compounded on a daily basis. So if you have paid attention in previous video about the formula, then you should have no trouble to understand n here. All right. So in my table now, you would see this formula. You see that? That's the formula to compute the future value of an annuity. Again, P here is not principal. P here is your regular payment. Let's process this example. At age 25, to save for retirement, you decide to deposit $200 at the end of each month into an IRA that pays 7.5% compounded monthly. Find the following answers rounded to the nearest dollar. Okay, so let me double check. I'm recording, I'm sharing. Okay, very good. So let's use the first method, formula. Okay. A equals, so we are looking for the future value. Yeah. A equals P times the bracket and 1 plus R over N. That's the compounding factor for this many times over the longevity of the annuity. And minus 1, close the bracket, all over your monthly payment, monthly interest. Okay, so payment P, $200. 1 plus annual interest rate 7.5%, so 0.075. At this point, you should be able to convert a percent to its equivalent decimal very quickly and correctly. Over 12. We can use a parenthesis here. Oh, no, I'm going to remove that. By writing, we don't really need that parenthesis. And this is a parenthesis to frame the compounding factor. And then to the power of 12 times t for how many years? Age 25. When you are 60, from 25 to 65, that is 40 years, right? So 12 times 40. 12 times 40. and then -1, and then close the bracket, all over 0.075 over 12. 0.075 over 12. It is okay, totally fine, if you can manually simplify part of the expression. For example, this part, and this part, you can simplify, right? But even you do not simplify, if you can learn this structure, you can just enter that expression exactly it is into the TI-84 calculator. If you have a scientific calculator, you're going to have tons of work to do, and the chance of making mistakes is also high. So that's the reason I strongly recommend, I repeatedly saying this over and over, you need a good calculator. Let's use the calculator. Let me share my camera. You're sharing HD camera and I'm not muted. Okay. Let's clear everything. And I'm going to enter this formula that we had earlier. All right. So this is what I would do. I would use multiple sets of, okay, sorry. How do you get out of from this app? Second mode, and you go back the regular calculation mode. So this is what I would do. I would do multiple parentheses, okay? This parenthesis is gonna frame the whole numerator. And I enter $200 and multiply another parenthesis. That parenthesis is the bracket. Now you should look at the expression that we had earlier. And then I'm going to enter another parenthesis. And in this parenthesis, I'm going to have the compounding factor. 1 plus another parenthesis, monthly interest rate, 0.075 divided by 12, close the monthly interest rate, and then close the compounding factor, and raise the compounding factor to the power of the number of times your interest is compounded. 12 times 40. Yeah, if you want, you can use another parenthesis, but I'm going to just calculate it in my head. 12 times 40 is 480. All right, and then I'm going to minus that, use that to minus 1, and then close the bracket. Okay, and then close the numerator, and then divided by the denominator. I'm going to use another parenthesis to frame the denominator. The denominator is 0.075 divided by 12. Close the denominator. Enter. I know it's very complicated. So if you like to just evaluate the expression by steps, that's totally fine. Okay? So we got the value. Let me copy the value on my note. The future value of this annuity, IRA account, savings retirement account, it is 604764. 4764. 4764. Yeah, round it down to the nearest dollars. Okay. Yeah, in 40 years, that's a very long time. You would have, that's a lot of money, right? Over $500,000. Yeah, if you really plan from when you are very young, you can really have a good life when you are older. Okay, so we still have the calculator. Here, I'm going to use the second method now. Second method, we go to the app, Finance, Time Value of Money Solver, and you will see the exactly same menu, and you just need to fix the values for each item on the menu. In this example, you contribute monthly for 40 years. So 12 times 40. You don't even have to calculate. The calculator would calculate it for you. So the total number of your contribution, the total number of your payments would be 480 over the longevity of the annuity. Interest rate is 7.5%. Again, do not convert to decimal when you are using this app. Present value 0. Present value for annuity is always 0. Your monthly payment is $200. Remember, do not use the minus sign, instead use the negative sign. And we are going to go back here later, so I put a 0 here. And very important, you must fix P per V, P per year, and C per year. In this example, you deposit your payment 12 times a year. And also your interest is compounded twice a year. So both two items supposed to be 12, not 1 anymore. Let's go back, future value, and make sure it's blinking at future value. And then you solve for it. Alpha, enter. All right, do you see the same amount? 604764. 604764. Yeah, exactly the same. Okay, so now I'm going to go back my note. And then show you the third method of solving the future value of the annuity. When you can contribute by month and when the interest is compounded monthly as well. Okay, so I'm going to use this cell, equal future value, left parentheses, rate. You know, this rate is not going to be 7.5% because your interest is compounded monthly, so it's going to be 0.075 divided by 12. Okay, and NPR 40 times 12, 480. Payment $200 every month. Present value is 0 for annuity. Type, present value is 0. Type is 0. Close. Same thing. Same value, exactly the same. All right. And the second method and third method is very fast, a lot faster than the first method. Especially you decide to manually to calculate that expression, to evaluate that expression, bigger chance for you to make a mistake. I'm just trying to make your job easier, okay? Part B, find the earnings from this investment. Earnings of the investment is your interest. Same with the previous example. Let's see how much money you contribute during the 40 years. You contributed $200 every month. We have 12 months every year. For how many years? 25 to 65 for 40 years. That's how much money you contribute, right? Yeah. Let's use a calculator quickly to find that value. 200. This can be done by using a simple calculator. Oops, that's a calendar. Calculator right here. 200 multiplied by 480 equals 96,000. 96,000. Right? 96,000. And your future value of the account is $604,764. And you subtract your contribution from that amount. and the difference would be your earning. Okay, so we are going to minus that. I'm going to just do it again. So 604,764 minus 96,000. 508,764. 508,764. 764. Okay. Is that 500,000? Yeah, 40 years basically is your whole life. That's your earnings from the invest. Hope not only you learn what is annuity and how to find the future value on the payment from the problems, but also you learn the value of those savings account, and you really can start to plan your future, your retirement. Next example, next topic. So we have, this section has two types of problems only. All right, as you can see in my table note, we only have two types of problems in this section. The first type is you are given the regular payment amount. You're looking for the future value. The second type is you know your financial goal in the future, and you need to determine your regular payment in order to reach that goal. So you are looking for payment PMT when A, the future value is given. Right here, this is the formula. Okay, regular payments needed to achieve a financial goal. The deposit P that must be made at the end of each compounding period into an annuity that pays an annual interest rate R, compounded n times a year in order to achieve a value of $8 after 2 years is given by this formula. If you are interested, you remember this formula, you use the first method. If you want to make your job easier, then you use my second method. And for this type of question, very, very important. Let me see, did I stress that on my table? No. We must round up the result. Yeah, I wish I include that in a table note. But my math assignments always give you a parenthesis and stress that. Round it up. Because if you do not round it up, there's a chance that your deposit is short and you will be a little bit short to achieve your financial goal in the future. So as you see here, in this section, we will round annuity payments up always. Here it says to the nearest dollar. I'm not sure about my lab math assignments. Maybe to the nearest cents is possible, but the important thing is always round it up. Let me switch this. Always round it up. Always round the payments up. Okay? Always round it up. We talked about round it up in previous section. Let's apply the formula and also show you the other two methods to find your payment in order to reach a certain financial goal. I need to double check. Okay. Suppose that once you complete your college education and begin working, you would like to save 20 grand over 5 years to use as a down payment for a home. That's a very good plan. Your financial goal in 5 years is 20 grand. You anticipate making regular end-of-month deposits in an annuity that pays 6% compounded monthly. How much money should you deposit each month? Okay, so this is the second type of problem, right? You know your financial goal. You're looking for your monthly payment, PMT, equals A times R over N, that's the numerator. Denominator is a bracket. Compounding factor. Watch my previous video to see what is a compounding factor. Plugging in the value. Your financial goal is 20 grand. 1, 2, 3, 4. Annual interest rate 6%, 0.06. Divided by 12, that's the monthly interest rate. Denominator, compounding factor 1 plus 0.06 over 12 to the power of 12 times t for 5 years. 12 times t is 60. 60 compounding periods and minus 1, right? So of course, you say, I want to make your expression too long in the calculator. Then what if I evaluate 0.06 by 12 and on my scratch paper? That's a very good strategy. 0.06, oops, let me do that again. 0.06 divided by 12 divided by 12 equals 0.005. Yeah, of course you can change that part to 0.05, right? Yeah, make your expressions shorter. 1, 2, 3, 4, and 0.0. What is it? 2 zeros. 0.005. And this is 1 plus 0.005 to the power of 60 minus 1. And then you would say, I can easily calculate this part. Right? Yeah, of course. Do that. Then next step, you would have 20 grand times 0.005. And in the denominator, you would have 1.005 to the power of 60 and minus 1. And make your expression simpler. And then you use the calculator. I totally agree with this strategy. Yeah. Okay, now eventually you still have to use the calculator, right? Depends on what calculator you are going to plan to use for the test. And when you practice, you should use the same method. Let me share my camera. Okay, so turn on my calculator. And second mode, we go back to the calculation format. Clear everything. And the numerator, remember we have, I'm going to use a separate parentheses to frame the numerator. 20 grand, 1, 2, 3, 4, multiplied by monthly interest rate 0.005, close the parentheses, and then divided by the denominator. I'm going to use a separate parentheses to frame the denominator. Structure. I always emphasize how important the structure of an expression is. And we have a 1.005 to the power of 60. And then minus 1. Your TI-84 calculator might be a little bit different, so you need time to get familiar with your calculator, the exact calculator you are going to use when you take the test. If you can pass this class or not, the test, play very, very important role. Okay, that's the value we got. We are going to round it up to the nearest dollars. So 287. Let me write it down. Is around equal to 287 every month. Every month, and in 5 years, you have your down payment to buy the house. In the future section, we are going to learn the mortgage. All right, that's the first method. Second method, let's use the TVM solver in this calculator, TI-84 calculator, very quickly. Go to Apps, Finance, TVM solver. You would see the same menu again. So you deposit 12 times a year for 5 years. So your big N is 60. Your annual interest rate is 6%, right? That's what I remember, 6%. So just 6. Your present value, again, annuity, present value of annuity is always 0 because it's ordinary annuity. You have nothing there until your first payment. Your first payment, put it 0 here. I'm sorry, your regular payment, put 0 here. We are going to go back in a moment. Your future value, your financial goal, how much you want? 20 grand, right? Yeah. So enter 20 grand, 1, 2, 3. And keep P per Y and C per Y as 12 because your interest is counted 12 monthly, and also you deposit your contribution by month, end of month as well. So let's go back. Payment, make sure it's blinking to the right of the payment, and you solve it. Do you see the same thing? 286.65603, right? Round it up, 287. That's the second method. That method is a lot faster. Let's go back to our note. Okay, and I'm going to show you the third method, Excel. This time I'm going to use this cell. It doesn't matter, any cell would be okay. So we are looking for payment. So PMT, remember to have this equal sign when you enter a function. Yeah, monthly interest rate is 0.06 divided by 12. 0.06 divided by 12. Monthly interest rate. 12 times a year for 5 years, so 60. Present value is 0. Future value is 20 grand for your down payment. And type is ordinary annuity, 0. Close, same thing. Okay? Yeah, the reason that is red because it's negative, because your money is going out. And for that future value, you can't just ignore the negative because when we enter the payment, we keep the payment positive. I don't think this makes a huge difference. You know, your future value is positive. Your payment is negative because it's going out of your pocket. When you invest money, and you would have to sacrifice, and you lose part of your income, right? Yeah, and how do you say that? For future happiness, you sacrifice your instant gratification, yeah, in the future. So your monthly payment is going to be around equal to 287 in order to reach your financial goal in 5 years to save for your house, the down payment. Part B, how much of the 20 grand? Oops. Okay. Let me do this. How much of the 20 grand down payment comes from deposits and how much comes from your earnings? Okay, so you deposit 287, right? That's what we got. Yeah, you deposit 287 every month. Every month. We have 12 months a year. For 5 years, you multiply 60, right? Oh, sorry, 5. And the money you deposit over the 5 years is going to be 287 times 60 equals 17220. 17220. that much money coming from you, and the rest 20 grand minus 17 grand 220, those money come from the account minus 20 grand 2780 2780. It looks the earning is not very impressive. It's because it's still good, by the way, because the 5 years is a shorter period of time. Okay, 5 years is short of period of time. So this money comes from you, comes from deposits. Yeah, dollars. You can put a dollar sign there. And this much of money comes from earnings or interest, right? So that's that question about funding the down payment. Funding the payment in order to reach a certain financial goal in the future. This example, let's look at this example. You would like to have $4,000 in 4 years for a special vacation following college graduation by making deposits at the end of every 6 months in an annuity that pays 7% compounded semi-annually. Part A, how much should you deposit at the end of every 6 months? All right, formula. What is the formula? Payment formula. You know what? Since this question is similar with the previous question, I'm going to use the second method only, all right? And I'm going to show you how fast this method is. And your future value is 4 grand. Yeah, you can write those on your scratch paper. Organize the information that is given from the question, by the question. So your n is going to be 2, okay? Lowercase n is 2 because semi-annually per year. And you also contribute every 6 months, end of every 6 months. So your R is 7%. What else? Financial goal, NR, for how many years? 4 years. So T equals 4. Okay, yeah, with those information given, you can use the time values of money solver to get a result very quickly. Let me share my camera. Okay. Turn on my calculator, and we are still here, right? Yeah, we were here earlier. So twice a year for 4 years, 2 times 4, it's 8, right? Yeah, semi-annually, twice a year for 4 years, then your capital N is 8. Annual interest rate, 7%. Simply just enter 7 here. PV, present value of annuity, always 0. Payment is something you are going to find out later, so put a 0 here for now. Future value, how much money you need? $4,000 just for a trip. 1, 2, 3. And here, very important, your P per Y. You pay twice a year. So payments every year is 2, not 12. Same with compounding period of a year is also 2, because your interest is compounded semi-annually. And leave the end because that's ordinary annuity, and then go back payment is blinking at payment, and then solve for the payment. How much do you have? If we round it up to the nearest dollar, 442. Let's go back our note. So if you deposit $442 every half a year, in 4 years, you have the money for your trip. Okay? And if we use Excel, let's do the Excel. Any cell would work. Just remember to put the equal sign. PMB, sorry, payment, PMT. And the left-ended parentheses, your rate is 7%, so we're gonna have to divide 0.07 by 2. And you don't have to do the calculation, you just enter that formula. And 2 times a year for 4 years, so 8. Present value is 0 for annuity always. Future value is $4,000, right? $4,000. Double check. For trip. Before inflation, yeah, that might be enough. And then we have the type is 0, ordinary annuity, and close the parentheses. Same thing, $442. You can use this to double check your answer. And Excel is free for anybody. Using your institution email address, your TCC email, you can get a free account from Microsoft and get those often used softwares for free. Yeah, Word, Excel, PowerPoint, and more. Outlook. Yeah. Part B, how much of those money comes from deposits and how much comes from earnings? So you pay 441, right? How much that is? Yeah, 442, sorry. 442 every half a year for 4 years. And that much money from your own deposit. So let's clear this. 442 times 8 equals 3536. 3536. So this money comes from, those dollars come from deposits. The rest, 4,000 minus 3536, that is 464. Those money comes from interest, right? Yeah, not a lot, but still, it's like more than 10% of your financial goal, and you only contribute 90% from the interest. Yeah, again, it's not very like as impressive as earlier previous examples, because those examples have like 20 years, 30 years, 40 years, and those is only like 5 years, 4 years. So it will make a huge difference, the time. This part is about the difference between traditional IRA and a Roth IRA. And what's the difference between traditional IRA and a Roth IRA? Roth here is a name of a Senate. Senate is the guy who sponsored and supported this type of new type of IRA. So they named this type of IRA after him. It's just a name, Roth IRA. The difference between traditional IRA and a Roth IRA is traditional IRA is tax deferred. You do not pay the tax when you deposit those money into the account, but you pay the tax when you withdraw those money in the future when you retire, when your tax bracket is lower. But Roth IRA is not tax deferred. You still have to pay the tax even you put the money in the account. Good thing about Roth IRA is the interests, your earnings. Sometimes they use the money to invest in other stock markets. Whatever the earnings in the account is tax-free always. Like here, your withdrawals are never taxed. Your withdrawal, not just the money you deposited, also the earnings generated from your deposit. Those interests are tax-free. So that's the advantage or attractive part of a Roth IRA. There's a difference. There's a difference between the two things. I think different type of IRA fits different type of people. I think for regular people like us, traditional IRA is better. And for people, because we assume we make more money when we are younger, and we make less money when we are older, right? But for some other people, they make more money when they get older. So those people, they want to use a Roth IRA. And even better, 401k and 403b, those retirement plan sponsored by your employer, those are the best. IRA stands for individual retirement account, is your personal plan for your retirement. You are the only one that contributed to the account. But if you are employed, you have an employer, very good employer, would like to give you a retirement plan such as 401k or 403b, then they will contribute, the employer will contribute to your account. And you will contribute a part of it. And your employer sometimes, most of the time, is to match your contribution. So your contribution will be doubled. So the last sentence here, all accounts designed specifically for retirement savings have penalties, tax penalties, if you withdraw before 59 and a half. Why this age? Because by common sense, we assume people want to get retired when they are getting closer to 60-year-old, right? Like by culture, yeah. Getting 60 year, I'm going to retire. So that's the age. You need to remember this for one of the questions in my lab math. All right, I think this is going to be the last example about the 401k plan. It can show you the benefits of this type of plan. Let's look at this question. We have 3 parts. Let's look at the first part first. Suppose that between the ages of 25 and 35, that's how many years? 10 years, right? You contribute $4,000 per year to a 401k, and your employer matches this contribution dollar for dollar. Yeah, contribution dollar for dollar on your behalf. So your payment, PMT. In the formula, we use P, but I'd like to use PMT. Would be 8,000, okay? Not 4,000, 8,000 per year. So everything is annually. Assume a rate of growth, so that's R, compounded annually. What's the value of the annuity? 401k retirement plans also annuity for 10 years. Yeah, the end of the 10 years. Okay, I'm going to use the app. Okay, I'm going to use the app. Yeah, write down those information on your scratch paper, and then we are going to use the time value solver to get a result quickly. Give you a little time to write down the information. T is 10 years. Your yearly payment $8,000. Annual interest rate 8.5% for 10 years. Yeah. Okay, so we are looking for the future value of the annuity. Let me share my calculator. Okay, I'm sharing the HD camera. Okay, so turn on my calculator. Yeah, we are still on here, right? So you shouldn't, by now you should know how do you get that mode. So annually for 10 years, once a year for 10 years. So big N is 10. Interest rate 8.5%, 8.5, very convenient, right? Present value 0 for any type of annuity. Payment is negative $8,000. 1, 2, 3. Yeah, because $4,000 from yourself, another $4,000 for dollar match from your employer. So annual contribution is $8,000. Future value is what we're gonna solve for. So put a 0 there. And P per Y, C per Y, what do you think that's supposed to be? 1, right? Because annually. So let's solve for future value. You can time me. It won't take too much time. Maybe just a few seconds, you can get it done. And that value is 18. Hold on. Future value. Oh, no, 18. It's blinking, so it's covering the first digit. Yeah, 118. For 10 years, that's a lot of money. $118,600. 79 cents. Let's see how do we round it. What does the question say? Rounding. What is the value? It doesn't say. It doesn't say. Let's just use the nearest cent. Yeah. When you work on your assignment, be careful the rounding instruction. 118. 680 dollars 79 cents. For 10 years, that's not bad at all. Okay, let's go back our notes. And I'm gonna use Excel just for fun to quickly double check my answer. All right, so here, use that equal future value. Rate annual is 7.5%. What is the annual interest rate? 8.5. My bad. 8.5. Did I enter 8.5 earlier? Yeah, 8.5. Yeah. So 0.085. 0.085. For 10 years, once a year, payment $8,000. We can totally enter negative 8,000, by the way. Present value is 0 for any type of annuity, and ordinary annuity 0, close. And now you have a black, right? In Excel, if the number is black, then that is a positive. Same thing with earlier. One thing about Excel is the rounding. Yeah, be careful with the rounding. But I double checked my answer correct. That is the value of the annuity, the 401k plan account in 10 years. In 10 years. That's part A. Part B. After 10 years of working for this company, you move on to a new job. However, you keep your accumulated retirement funds in the 401k. How much money will you have in the plan when you reach age 65? Make sure I'm not muted and I am sharing and I'm recording. Okay. So you know what? You will see similar problem in my lab math. Yeah, so please pay attention. So after 10 years, the value of your plan, your account is 118680. 118680. Let's round it to the nearest cents, 79 cents. All right, and that is gonna be what? your original principal. So you left the job, then that account now is going to be a regular account, pays you compound interest. Okay, so not annuity anymore because nobody gonna contribute. By the information, nobody gonna contribute after 10 years. So this is the value, the money you put in an account, you have in an account. So that's gonna be the original principal. Okay, yeah, switch the gear. This is gonna be the original principal. Part B actually is a compound interest problem, has nothing to do with annuity. Okay, so how much money will you have in the plan in the future? So we are looking for the future value. Accumulate the balance of the plan when you reach 65. So how old now in 10 years? 35, yeah. So 35 to 65, that is 30 years. Okay, so T equals 30. T equals 30. And do you remember the formula? A equals P times 1 plus R to the power of T, right? When N equals 1, when everything is by year, by 1 year, once a year. So you can totally plugging in to find the value. But we can also use the app, Time Value Solver. In previous video, I shown you the shortcut to find the future value for a compound interest account. Let me share my calculator again. Yeah, make sure you can switch the gear. We are now not doing the annuity anymore. We are doing a compound interest account. So once a year for 30 years, interest rate stays the same. Okay, interest rate stays the same. Present value is not zero. 118. Yeah, it's very convenient. It's still there. 118,680.79. That is your original principal. Okay. Your payment, because nobody contribute anymore, is zero. Just keep it at zero. And future value is the value you are going to solve for. And P per Y, C per Y are all 1. And we solve for that. We have 1371742. Okay. Let me copy the value right here. Oops. Future value is 1371. 742.44. If we round it to the nearest cents, really? Let me double check. 1371742. 1371742.44. You're gonna have over $1 million when you are retired, only because you work for that company only for 10 years. All right? You see that? Yeah, the future value of the account, even you abandon the account, you do not contribute anymore. But after 30 years is a very long time, and the interest rate 8.5% is very high. And you will have over $1 million, 1.3 million, almost 1.54 million when you retire. Okay, so let's go back our notes and look at the part C. Part C. What's the difference between the amount of money you will have accumulated in the 401k at age 65 and the amount of you contribute to the plan? Okay, so you only contribute for 10 years and once a year, and you only deposit $4,000. Let me double check. Yeah, only 10 years and you deposit 4,000. Another 4,000 is from your employer. So yes, you only do 40 grand. You only contributed 40 grand for over the 10 years. But by the end of the by your age 65-year-old, and you have this much money in your account, and the difference is 67 742.44. Let me double check. You remove the 40 grand. 40. Oh no, hold on. 40 grand. No. Let me redo it. Minus the 40 grand. So it's 1331742.44. And you remove 40 grand from here. 40 grand. 2, 3. So you have 1331742.44. And that's your earnings. Okay, that's the difference. That's a very good employer. Not sure why he ever left that company. So over $1 million. That's how beneficial a 401 plan could be. All right, that's the end of the note. I hope you can watch the video, especially pay attention to the second method. When we solve for future value of an annuity or the regular payment amount to reach a certain financial goal in the future in your annuity by using the time value of money solver in TI-84 calculator. Okay guys, everything for today. Please feel free to email me if you have any questions about this section. I'll see you in the next video.